Hello everyone, I'm Alice Gavya working as assistant professor in a private institute. So in this video we are going to discuss about producer consumer problem. So first let's see the introduction. This producer consumer problem can also be called as bounded buffer problem. It is one of the examples for a multi-process synchronization problem. In producer consumer problem we are having two processes. The first one is producer and the second one is consumer. Both the producer and the consumer going to share a common fixed size buffer. This buffer will act as a queue. So what is queue? Queue is nothing but a data structure in which the element which is inserted first will be removed first. So who is producer? So producer is the one who is going to add some data into the buffer. And what is the role of consumer? So consumer is the one who is going to consume or utilize or remove the data that was produced by the producer. So the producer task is to generate the data and it has to be loaded into the buffer. And consumer is going to consume the data that was produced by the producer. So normally consumer can able to consume only one piece of data at a time. So in case of producer consumer problem, we need to make sure about two things. So first one is producer should not add data into the buffer if it is full, and consumer won't try to remove data from the empty buffer. That is, actually we are having two cases. So first case is what will happen when the buffer is full. Whenever my buffer is full, producer should not try to add any data into it. And case 2 is what will happen when my buffer is empty. Whenever the buffer is empty, consumer should not try to remove any data from it. So let's see an example. So I am having a buffer which is going to share by both the producer as well as consumer, and the size of buffer is 5. And in this scenario my buffer is full. It was loaded with data and I'm having no free slot in it. So here comes the producer. So who is producer? Producer is the one who is going to add some data into it. So whenever my buffer is full, producer cannot add any data into it because I can't able to find any free slot in my buffer. So what producer will do now? They will simply go to the sleep mode. So here comes the consumer. So consumer is the one who is going to remove the data that was produced by the producer. So consumer can able to consume only one piece of data at a time. So once the consumer consumes all the data from the buffer, we can able to get free slot. So whenever there is a free slot in my buffer, a notification will be sent to the producer so that producer can add the data into the buffer. So what happens when my buffer is empty? So when the buffer is empty, consumer cannot able to consume or utilize or remove the data from the buffer. So what consumer will do now? Again consumer is going to sleep mode. So when a data is added into the buffer by the producer, a notification will be sent to the consumer so that consumer will awake from the sleep mode and they are going to consume the data that was produced by the producer. So before we are going to discuss about the sample code, we are going to see the variables that are used for the producer consumer problem. So we are using two main variables. So first one is fill count and the next one is empty count. So fill count is a variable that is used to refer the number of items that is currently present in the buffer, and empty count is the variable that is used to refer the free slot in my buffer. So in this example, I am having a buffer whose size is 5 and it having some 5 free slot. Initially my buffer doesn't load it with any kind of data, so I'm having 5 free slot. So fill count is a variable that is used to refer the number of items currently present in my buffer. So initially my buffer doesn't contain any item in it, so fill count was initialized to the value 0. And empty count is a variable that is used to refer the empty slot. So initially my buffer doesn't load it with any data and I can able to find free slot as 5. That is, I'm having 5 free slot. So I'm going to initialize the value 5 to the empty count. So full count is a variable that is used to refer the number of item that is currently present in the buffer, and empty count is a variable that is used to refer the free slot in the buffer. So what will happen when a data is added into the buffer? So whenever a data is added into the buffer, we need to increment the value of fill count and we need to decrement the value of empty count. So initially fill count was initialized to 0 and empty count was initialized to the value 5. So what 5 refers to? 5 refers to the maximum size of the buffer. So when the data added into the buffer, we have to increment the value of fill count. So fill count was initialized to 0 initially. So after increment it becomes 1. So when a data is added into the buffer, we need to decrement the value of empty count. So initially I have assigned the value 5 to the empty count. So after addition of a particular data, it was decremented to 4. So what happened when a data was consumed? Whenever a data was consumed, we need to decrement the value of fill count and we have to increment the value of empty count. So as I told already, fill count is a variable that is used to refer or identify the number of items that is currently present in the buffer, and empty count is a variable that is used to find the empty slot or free slot in the buffer. So here we are having two functions, one for producer and the other for consumer. So producer is the one who is going to add some data. So whenever I am having some data to be added, I have to decrement the value of empty count and I have to increment the value of fill count. And my second function is consumer. So consumer is the one who is going to utilize or remove the data that was produced by the producer. So when the consumer function gets called, we need to decrement the value of fill count and we need to increment the value of empty count. So empty count is a variable that is used to identify the free slot, and fill count is a variable that is used to identify the number of items currently present in the buffer. So we are going to discuss about one more scenario. So what happens when we have more than one producer who is trying to access the same resource at the same time? So normally we shouldn't allow such type of scenario. So this problem can be solved by using mutual exclusive. So what is mutual exclusive? So mutual exclusive prevents the simultaneous access to the same resources. That is, more than one producer cannot able to add data into the same resources. Similarly, more than one producer, that is more than one consumer, cannot able to consume the data at the same time. That is, mutual exclusion is used for preventing the simultaneous access to the shared resource. More than one producer or more than one consumer cannot able to access the same resource. So to implement the mutual exclusive concept, we are using one more variable called mutex. It was initialized to the value 1. Again, here we are having two functions, one for producer and the other for consumer. So whenever the producer function gets called, we need to decrement the value of empty count and we have to decrement the value of mutex. So mutex is nothing but it refers to mutual exclusive. It was normally initialized to the value 1. So after decrements, the mutex value becomes 0 so that no more producer comes into the picture. So once the producer added the data into the buffer, we are going to increment the value of mutex. That is, again the mutex value will becomes 1 from 0 and we are going to increment the value of full count. So once the mutex value becomes 1, the second producer can comes into the picture and they can able to add some more data into the buffer. And here we have the consumer function. So consumer is the one who is going to utilize the data that was produced by the producer. So whenever a consumer function gets called, we are going to decrement the value of full count and similarly we are going to decrement the value of mutex. So initially mutex was initialized to value 1. So once the first consumer comes into the picture, it was changed into 0 so that the second consumer will not come to the picture to access the same resource. So once the consumer removed the particular data from the buffer, we have to increment the value of mutex and we have to increment the value of empty count so that the second consumer can comes into the picture to consume the data. So after watching this video, you can subscribe to my channel and you are welcome to give some feedback. So thanks for watching this video. If you have any queries, you can post it. I try to send response to you as soon as possible. So thank you.